Hello everyone, I am Dr. Bhavna Mohite from Bajaj College of Science, Wardha. Today I am going to present my work on potential of bacterial exopolysaccharide for environmental application, and specifically I am focusing on heavy metal cleanup. We all know that heavy metal pollution is a major concern in today's scenario, as it's going to cause the toxic effect on food chain affecting the whole ecosystem as well as human health. So the traditional techniques, though it is used on industrial scale, but it's having involvement of high capital and operational cost, high energy utilization, and production of large amount of toxic compounds which are unsafe for the environment. So bioremediation is not only the cost effective solution for this, but that is also safe and effective in nature. So bacterial biosorbent, it is having an effective metal sequestering property that can reduce the heavy metal concentration from ppm to pbb level. So comparing with the conventional methods, the heavy metal removal by bacterial remediation, it having the cost effective, efficient and eco-friendly nature. So I am focusing here particularly the bacterial exopolysaccharide production ability of the organism, as this EPS is going to help for the metal sequestration. The exopolysaccharide, it's going to be either the capsular one or the secreted one. So particularly the secreted EPS here is going to focus in the study. So why EPS has the ability to bind with heavy metal ions? So thing is what ki EPS produced by the bacteria as a protective response against the stress condition. So when EPS get produces, it can able to bind with this heavy metal ion with the electrostatic interaction, and that's why we can use it for the purpose of metal removal. And also it has been observed that there is a enhanced production of EPS when it is get exposed to the heavy metal ions. So this binding of toxic metal ion to exopolysaccharide, it facilitated further the metal transport and further the anticipating its metal toxicity. So that's why we decided to go with study of effect of heavy metal ion and the EPS production. Here you could see that what is the actual mechanism for EPS and binding with heavy metal ion. So as the anionic property is there for the exopolysaccharide, as it is having a negatively charged functional groups, including phosphate, carboxylate, acetate, amine. So those going to bind with the positively charged metal ions, and this coordination bonds by the carboxyl or hydroxyl groups, it gives the stability to that metal ion when it is going to form a complex with exopolysaccharide. And so that's why we decided to go with heavy metal tolerating exopolysaccharide production producing bacteria to get search and see that what are the heavy metal stress consequences on the bacteria. So the methodology we designed, it started with the isolation and identification of EPS producer, then studying the effect of heavy metal stress on EPS production, and enumerating the heavy metal accumulation and what is the effect of heavy metal stress on the bacterial morphology as well. So we studied 93 EPS producing isolate, among which the potent one, which is coded as SVMRE, was selected for the study, which was identified by morphology, biochemical and molecular techniques as Pantoia agglomerans. So here you could see that among the isolates we found this Pantoia is found to be more potent, which was here you could see it on the solid plate agar, giving the type of moist and copious amount of exopolysaccharide produced here. Here you could see it in a liquid media, and by negative staining you could confirm that there is a large amount of EPS get produced surrounding the cell. Then I have screened the heavy metal tolerance of this Pantoia agglomerans by exposing the organism towards various heavy metal ions. So here you could see that compare with the untreated cell, when it is get exposed to the heavy metal, so it show the tolerance, it get grow, and even the EPS production is found to be get increased in comparison with the untreated cells. So when it is not having any exposure of heavy metal ion, it is giving a high amount of production of EPS compared with when it is untreated cell without any exposure of heavy metal. And further, that metal, it is been accumulated within a bacterial cell, that is confirmed with EDX, seeing the different heavy metal ions in the bacterial cell compared with the control. Then further with FE same scanning electron microscopy, the change in the cell morphology was checked compared with the control. That effect of heavy metal is going to change the morphology of the bacterial cell. Then with ICP AES, the metal accumulation get confirmed with respect to the absorbed metal ions and the cell bound metal ions. And along with that, it was said that when this metal ion takes inside the cell, get accumulated or absorbed, there is a release of divalent ions like calcium ions. Compared with the untreated cell, the release of calcium ion is found to increase. And with FTIR, we confirm the functional groups which is involved in metal binding. With transmission electron microscopy, the site of metal accumulation is confirmed, as well as what are the possible structural changes. You could see here that the cell membrane is going to get disordered, or what is the exact location for the metal accumulation, that is been also confirmed with TEM. And you could see that with respect to the different heavy metal exposure, it going to show a different effect compared with control. So it's confirmed that there is a accumulation of metal ions which is by cell bound EPS, as well as some intracellular deposit of the metal ion was also observed. Along with that, it was found that when there is a effect of heavy metal, or when it is exposed to the heavy metal, then it is found that the total protein ion content was decreases while the carbohydrate content was increased. So here by this all, we conclude that in present study we put forward the indigenous exopolysaccharide agricultural isolate, which was identified as Pantoia agglomerans, as a potent organism which is going to cause the metal accumulation, and that changes with respect to the metal stress. So it found to tolerate the various heavy metals like silver, arsenic, lead, chromium, cadmium, and that is get selected based on their ecological significance. Then when we discuss this heavy metal stress, so we found that the heavy as a effect of or as a response to the heavy metal, the morphology of the cell, it get changes. There is a release of divalent ions by replacing the heavy metal taking inside the cell, and going to cause the release of the calcium ion outside the cell. This changes which is caused by the heavy metal stress, it is very specific for the specific metal ion. So the metal binding behavior of EPS here, when what it was revealed, so it shows that it is having a great ability that it can complex with the heavy metal, and thus it can protect the cell from that metal stress. So we put forwarding here the important agricultural isolate Pantoia agglomerans, that could be the potential candidate for the bioremediation process in metal contaminated area. These are some of the references. I am thankful to the organizer for giving me the opportunity to present my work for this conference. Thank you.